Welcome back. Today we're going to look at an experiment that defies the law of conservation of energy. Or does it? You'll notice that Laika the space dog's not with us again today. She's off on another one of her world travels, and more of that at the end of the video. So a while back, Barry was given this Busy Train book by a really good friend of ours, and he absolutely loves it. And what it consists of is some really thick cardboard pages. That's not so much so that he can't tear them, but it's got a track cut into it. And it comes with a little toy train. So I'll show you this working, and then I'll show you why it might disobey the law of conservation of energy. So if you've seen one of these before, you'll know how it works, but I hadn't seen one. So what we've got is the little train, and it's got its 4 normal wheels and a little wheel in the centre. And what you do is you put it on the track, you pull it back to the beginning, and you let go. And he loves watching this, and it just seems to go on and on and on and on. But what I want to discuss is, does it disobey the law of conservation of energy if it goes so far when I've only pulled it back a very short distance? So let's look at this in a little bit more detail. Right, so let's take a closer look at this. So here's the start. I'm going to put the little train here, and I'm going to pull it back, and that's about 25 or 30 centimetres. So there was no energy in the little train, and I'm now going to release it, and off it goes, and it's done. It's 25 centimetres, and it's gone round the track, and it's gone again, and it's gone again, and there we go. It's working its way uphill a bit there. But I think you'll agree that I only pulled it back 25 centimetres, and yet it's probably gone 5, 6, 7 times that distance. So does this defy the law of conservation of energy? How is it I can just pull it back a short distance and it can go way further than I pulled it back? Have you got any ideas? Perhaps we'll pause for a minute now and give it a little bit of thought and see what you think's happening. So I wonder what answers you came up with. I guess a lot of you said it might have a battery in it, and that battery gives it the extra energy it needs to keep it going on the track. Okay, well, I can't prove it to you without breaking it, and that wouldn't be fair on Barry, but there's no battery inside this. Okay, so I think those of you who know these sort of toys will have said something else. You would have said, but it's got a wind-up clockwork mechanism in it. So that's where it gets the energy from. And you only have to pull it back a short distance and you get loads of energy out because it's got a clockwork mechanism. But I'd like you to think about that in a little bit more detail because you're making a little bit of a mistake with your physics. I'm not sure what other ideas you might have come up with. Maybe you can tell me in the comments. But we've basically got the battery. It doesn't have one. The clockwork motor, which it does have, and that's the key to how it keeps going. So let's look at this clockwork motor. Okay, I think you agree this is a kind of wind-up toy, and you wind it up by pulling it back to the start of the track, and energy goes into the car, or in this case the little train, and that energy is released as it goes around the track. But we still haven't got to the bottom of why I pull it back such a short distance and it goes so much further. So let me try and explain that now. So to explain this lovely toy, you need to know a little bit about energy. And when the little train is taken out of the book and he hasn't been playing with it, there's no energy stored inside the train, inside its mechanism. Okay, but when you pull it back, what you're doing is converting chemical energy in yourself to kinetic, pulling the the train back, and that kinetic energy winds up a spring in the mechanism, so it gives it elastic potential energy. Okay, so is it giving out more elastic potential energy than you put in when you pulled it back, because you only pulled it back a short distance? And that's the key to whether it's defying the law of conservation of energy or not. We need to look at how the maths, I'll keep it very simple, of energy transfer works. So here goes for an explanation. Now, what's the likelihood that a toy that Barry's got defies a law of conservation of energy, one that stood up to the test of time in physics for hundreds of years? Well, nil. Okay, YouTube might be covered with videos that say they are sort of defying the law of conservation of energy or free energy or all those sorts of things. But the energy that this little train got came from me. Okay, so now I need to very quickly explain why I only pull it a short distance and the train is capable of going much further. I wonder if any of you knew. It's so obvious if you know some GCSE physics, but the point is, can you find the right bit of physics to apply to this? So here we go. There's a clockwork mechanism in here, and all the clockwork mechanism does is store energy. It doesn't make energy, it doesn't produce more energy than I fed in, it's just a store of energy that releases it. The next thing you need to know, and you might remember from GCSE or even O-level days, is that energy transfer, in this case, depends on two things. Okay, it depends on distance, yes, okay, but it depends on force as well. So the energy transferred mechanically here into this is the force I push with to pull it backwards multiplied by the distance I move it through. And that's the key to explaining why I pull it a short distance and it, when I release it, goes much further on the track. So we said energy transferred is force times distance. So I'm going to put some energy into this. I'm going to put some elastic potential energy into the spring in the wind-up mechanism. And I'm going to pull back. And I can't show you this on a video. I suppose I could put a spring balance here. But I'm pulling back quite hard, actually. Okay, I can feel I'm working against the spring. So I've done a large force through a small distance. And here's the energy coming back. A very small force to drive the train through a large distance. And there we go, it's going to keep going. Oh, just about got caught. Bit more energy left in there from me. So it's not defying the law of conservation of energy at all. So briefly, just to look at this in a slightly more mathematical way, if I pull back with 5 times the force that it needs to drive itself around the track, this distance, it'll go round the track with 1/5 of that force, but it will go 5 times as far as I pulled it back. Well, okay, maybe not quite 5 times because it's wasting a little bit of energy as heat and friction, and it was making a little bit of sound. But this thing is not making energy at all. It's getting all its energy from me, and it's certainly not defying the law of conservation of energy. I just hope at some stage Barry will understand all of that. So, hope you enjoyed that video and you learned a bit more about the law of conservation of energy. I'll be making another video soon and I look forward to seeing you then.